Hello class, this is lesson 7-3 in your textbook, and it's titled How to Define and Use Zero and Negative Exponents. So we've talked a lot about positive exponents in our previous two lessons. Now let's begin with, if you see zero as an exponent, what do? Well, anything to the zero power is going to be 1. The only exception is when a is 0, so that can't happen, okay? But any other time, if you have negative 1 billion to the 0 power, it's going to be the number 1. So for example, if you see 5 to the 0 power, that's going to be 1, okay? Now let's talk about if you see a negative exponent, okay? So if you have some number to the negative n exponent, really you're just going to write the reciprocal of whatever you see to that positive exponent. And again, a cannot be 0. So if you see 2 to the negative 4 exponent, that's the same as 1 over 2 to the 4th power, which is 1 over 16 when it's fully simplified. Okay. The last one is if you just see a number to a positive exponent, it can also be rewritten as 1 over that number to the negative exponent by writing the reciprocal. And again, a cannot equal 0. So for instance, if you just see the number 3, which is to an invisible 1, really that's the same as 1 over 3 to the negative 1 power. So why don't we go ahead and let's do some examples based on this new information that we're adding to our repertoire. The first one is 6 to the negative 2 power. Okay, so I'm going to rewrite this as 1 over 6 to the positive 2. And 6 squared is 36. So this would equal 1 over 36. Okay, here's our next one. X to the 0 power. Well, again, whatever I said, any number, as long as it's not 0 to the 0 power, is going to be the number 1. That's it. Easy. Here we go. Let's move on. 2/3 to the negative 2 power. So don't get tripped up just because you see a fraction there. This is going to be 1 over that fraction, 2/3, and we're going to square it. Now it's going to be positive. So this means 1 over 4/9. And if you are dividing a fraction on the bottom, that's the same as writing the reciprocal for 9 over 4. Okay? And we're done. Last one, 0 to the negative 7 power. This would be 1 over 0 to the positive 7, but this is something that cannot ever happen. We can't have 0 on the bottom, which means that this will just be undefined. Okay? So why don't we move on now? Let's review some of the things that we learned in yesterday's lesson. Okay, the first one that we talked about was if you saw a to some exponent times a to a different exponent, but they have the same base, what you're going to do is you're going to write that base and you're simply going to add those exponents. Okay. Then if we have a to the m exponent, and then that whole thing to the n, we're going to multiply those. And that's going to be our new exponent there. If I see some number times something else to the m exponent, this is really a to the m times b to the m. Okay. If you had a to the m divided by a to the n, we are going to subtract those exponents. And the final one, if you have a fraction to an exponent, like in the example we just did, that's the same as a to the m divided by b to the m. Okay, so we'll use this knowledge with the 0 and the negative exponents that we just learned about to solve the next couple problems. Okay. Our first one says negative 2 to the negative 5th exponent times negative 2 to the positive 5th exponent. So if I was going to rewrite this, this would be negative 2 to the negative 5 plus 5, which is negative 2 to the 0 power, and anything to the 0 power is 1. So that was kind of easy. Okay. Next up, when I see two exponents like this, I'm going to multiply them. So this is 3 to the negative 6, which is the same as 1 over 3 to the positive 6. And that, my friends, is 1 over 729. I could have asked you to multiply that all the way out, 3 times 3 times 3 times 3 times 3 times 3, but this is what it is. So here we go, moving on. Next one is 1 over 8 to the negative 2 exponent. If I'm going to rewrite this, I can rewrite it going to the top as 8 to the positive 2, which is the same as 64. And our final one on this page, 7 cubed divided by 7 to the 5th power. Using what I know about exponents, this is the same as 7 to the 3rd minus the 5th power, which is 7 to the negative 2. And if I'm going to rewrite that, it's going to be 1 over 7 to the positive 2, which is 1 over 49. So I hope you're getting the hang of this now. Okay, we're always trying to look for having a positive exponent in the end or simplified all the way out. So I have two examples for us. And I want us to leave our answer with positive exponents. Okay, so no negative exponents. So what we're going to do is we are going to use this 3 as the exponent and distribute it throughout the whole thing. So really this is the same as 3 cubed, and then this would be x to the negative 6 and y to the positive 6. Okay. Then I can rewrite this and move this x to the negative 6 underneath. So this is going to be 3 cubed y to the 6 divided by x to the positive 6. So I have my answer now in only positive exponents. And let's just see if there's anything else that I can simplify. I can simplify this 3 cubed. That's going to be 27 y to the 6th power divided by x to the 6th power. And I'm done. So not too bad. Okay, this one was pretty easy. I have one more for us now. This one is 2x to the negative 2 exponent, that whole quantity, times y to the 5th divided by negative 4 x squared y squared. Okay, so the first thing that I want to do is take care of this right here, this 2x to the negative 2 exponent. And so I'm going to distribute it through. This is the same as 2 to the negative 2 times x to the negative 2 times y to the 5th divided by negative 4x squared y squared. Okay, now that I have that done, how about we move these negative exponents down below? So really this is the same as, I'm going to leave the y to the 5th up above, and this 2 to the negative 2 is now going to be 2 to the positive 2 times x to the positive 2 times negative 4 times x squared times y squared. Okay, and now we can combine some like terms. For instance, 2 squared is 4, and 4 times negative 4 is negative 16. And x squared and another x squared, remember you add the exponents, so it's going to be x to the 4th and y squared. So I'm almost done. I have everything now in positive exponents. I have the numbers combined, but I have y's on the top and y's on the bottom. So remember, this is the same as they're being divided. So really that's y to the 5th minus 2 if I was going to move that to the top. And I would still have the negative 16 x to the 4th on the bottom. And y to the 5 minus 2 would be y cubed divided by 16 to the 4th, and I'm going to put my negative sign out in front. And that is my final answer in simplest form. Okay, so I have a problem for you to try on your own. I want you to simplify it and leave it with positive exponents just as we did. And what it says is 4x to the negative 2 power times y to the positive 4 divided by 8x y to the positive 6 power. So come with any questions that you have to class, and I'll help you out when I see you.